Welcome to this class. Today I am continuing the chapter Pressure of the subject Science and Technology of class 10, and it is taken in the unit number 8. We have divided this chapter into 7 different parts. Out of those 7 different parts, today I am presenting this part number 6. And in this part, we are going to talk a lot about the Archimedes principle. Exactly what is Archimedes principle and how can we experimentally verify Archimedes principle and how can we prove Archimedes principle by derivation, what are the uses of Archimedes principle, etc., etc. Today's focus is on Archimedes principle. But Archimedes principle is related to upthrust. It says something about the upthrust. So we have to recall first upthrust and then we'll enter into Archimedes principle. Look at this. What is upthrust? We can say with the help of diagram we can understand first. I want to recall the upthrust with the help of this diagram and then we'll proceed. Look at this is a piece of wood. If it is placed in water and if it is pressed inside the water, it will go down, and when we release our hand, it will come again up this way. If we try it again, then again it comes up. What it means? It means when a body is placed in a liquid, then liquid applies a vertically upward force on the body. Because of this vertically upward force, this piece of wood is coming up. And this is vertically upward force which is called upthrust, and this upthrust is also called buoyant force. Now we can define upthrust this way. The resultant force acting vertically upward on a body when placed in a liquid is called upthrust or buoyant force. Since it is a force, that's why it is measured in Newton. Look at this, resultant force is told because when a body is immersed in a liquid, then liquid exerts force from all the sides. Resultant of this force acts in one of the sides and this side is in the upward direction. That's why direction of upthrust is vertically upward. This is resultant force. Okay, how do we measure upthrust? This also I want to recall from previous class. Measurement of upthrust. For the measurement of upthrust, I want to show you diagrammatically. Look at this is a body and its weight is taken in air. Let's say its weight is 10 Newton. When we immerse the same body into water, then certainly its weight reduces because water applies an upward force on the body. Because of this applied force, upward force which acts against the weight of the body, weight reduces. Now weight will be less than 10 Newton. Let's say it is 9 Newton. It means we can easily understand that 1 Newton is the upthrust, which can be measured by using this equation. Upthrust is equal to weight of the body in air minus weight of the body in liquid. If we have to find the upthrust exerted by liquid on a body, then take the weight of that body in air and again take the weight of that body in liquid, and if we subtract the weight of liquid with weight in air, then we will get upthrust. Then upthrust can be symbolically written as U, and this is equal to weight in air minus weight in liquid. In this case, weight in air was 10 Newton, weight in water is 9 Newton, that's why 10 Newton minus 9 Newton, 1 Newton is the upthrust. Okay, this is all about the upthrust. We need this upthrust to understand this Archimedes principle clearly, so I recalled these two matters, measurement of thrust and upthrust. Now let's talk about Archimedes principle. Archimedes, a great scientist, what he told, that is called Archimedes principle. He made a principle. According to Archimedes principle, when a body is partially or completely immersed in a liquid, it experiences an upthrust equal to weight of displaced liquid. Look at this again. When a body is partially or completely immersed, whether the body is floating, in case of floating, it is partially immersed. In case of sinking, it is completely immersed. Whether the body is floating or sinking, it doesn't make any difference. Archimedes' principle is applicable for both the cases. Whether the body floats or sink, Archimedes' principle acts in both the cases. According to Archimedes' principle, when a body is partially or completely immersed in a liquid, it experiences an upthrust equal to weight of displaced liquid. This is the key point. What is the heart of this Archimedes' principle? Upthrust is equal to weight of displaced liquid. This is the heart of Archimedes' principle. That's why I'm writing as equation also. Upthrust is equal to, is also called buoyant force, is equal to weight of displaced liquid. Let's understand about this Archimedes' principle with the help of animated diagram. Let's say a vessel contains water and a piece of iron is taken in it. Certainly it sinks in water because it is denser than water. Now it experiences upthrust which acts vertically upward on the body, and the upthrust acting on this piece of iron, according to Archimedes' principle, the upthrust acting on this piece of iron is equal to weight of displaced liquid. If this is the size of this body, then the volume of the body is equal to the volume of displaced liquid because it displaces the liquid according to its volume. What is the volume of this body? The same volume of water it will displace. And let's say this is the volume of the water displaced. And according to this principle, if we take weight of this displaced water, then the upthrust will be equal to weight of this displaced water. If weight of displaced water is 2 Newton, which is equivalent with the volume of the body because body is immersed. If weight of displaced water is 2 Newton, then upthrust will also be 2 Newton. This is Archimedes' principle. Archimedes' principle says so. Now let's talk about a floating body also. Let's say this is of same volume. This is a piece of iron, let's say, and this is, let's say, this is a piece of wood. Wood floats on the liquid. We are taking water. Wood floats on water. Now, a part of wood is inside the liquid, a part is outside the liquid, and this is called floating. Whether more part is inside the liquid or less part or more part is outside the liquid, it doesn't make any difference. If a part of the body is inside the liquid, a part is outside the liquid, then the body is said to be floating. The piece of wood which has same volume is floating here. But what do you think? It experienced the same 2 Newton of thrust? No. The weight of displaced liquid by this floating piece of water is less. And that's why the upthrust acting on this body will be less. Look at this. I want to show the amount of liquid which it displaces. Less part, this part, immersed part displaces the less amount of water. And weight of this water is certainly less than 2 Newton because this much amount of water, if weighs 2 Newton, this much amount of water weighs less than that. Let's say it is 1 Newton. The same volume but immerse less. That's why the upthrust is less, because upthrust is equal to weight of displaced liquid. It displaces less weight of liquid, that's why upthrust is less. It displaces more liquid, that's why upthrust is more. Okay, I described a lot about the Archimedes principle, but the key point we have to remember, according to Archimedes principle, upthrust is equal to weight of displaced liquid. Now, we are going to prove it experimentally. How can we prove Archimedes principle? I want to go through experimental verification of Archimedes principle. Now let's talk about this with the help of animated diagram. I made this diagram to make you comfortable to understand all this. Let's say an object is weighed in air and its weight is, let's say, W1, maybe 10 Newton, 20 Newton, whatever it is, but symbolically it is represented by W1. A body is weighed in air, its weight is W1, and an arrangement is made in such a way that I'm going to immerse this body into this water, and water is taken in Eureka can. It is completely filled with water. No more water can be added in this Eureka can. If we add more water, it will come out through spout. It's completely filled. And my planning is to immerse this body into water. Now, if I immerse this body into water, then certainly certain amount of water it displaces, it goes out through the spout. So to collect that, I am using top pan balance. Since the balance is at the top, I mean to say pan is at the top, so this balance is named as top pan balance. Now, an empty beaker is taken over it, and if any water comes from this Eureka can be collected in empty beaker. After this arrangement, now I want to take the weight of this beaker also. Let's say weight of empty beaker is W3. Till now we have taken two values. One, weight of the body in air, W1, weight of the empty beaker, W3. Now I am going to immerse this body into this water. Look at this. If we immerse into water, then what happens? Then the weight doesn't remain W1 because it reduces. We know about this because in previous class also we learned about this at the beginning of this class also I told about this. Because of the upthrust, weight will be less. Now it will be different than W1. Let's say it is W2. W2 is less than W1. Now this difference of weight is upthrust. Upthrust equal to W1 minus W2. You know about this. Now, what do you think? When it is immersed into the water, then water certainly goes out, and we are going to collect this water in this empty beaker. Now, beaker will be filled with this displaced water. Displaced water comes out and goes to empty beaker. Now, the combined weight of this beaker and displaced water wouldn't be W3. It is more than W3, isn't it? Because previously we were measuring the weight of empty beaker. Now the weight of beaker plus displaced water is certainly more than W3. Now the new weight is, let's say, W4. Now W4 is the weight of beaker plus displaced water. And if we have to find the weight of displaced water, then we can subtract W3, the weight of the beaker, with W4, weight of the beaker and displaced water. Weight of displaced liquid is equal to, in this case we are taking water, but normally we can say that this liquid may be anything, that's why liquid word is used here. Weight of displaced liquid is equal to W4 minus W3. Now, what is found experimentally? W1 minus W2 is found to be equal with W4 minus W3. It means this W1 minus W2 is upthrust. Upthrust is found to be equal with what? Weight of displaced liquid. So the result of this experiment is upthrust is equal to weight of displaced liquid. This way we can verify Archimedes' principle experimentally. I think now you are clear, isn't it? This is experimental verification of Archimedes' principle. But if you have to write somewhere, you cannot show this animated picture, isn't it? Animated diagram cannot be shown. That's why while writing, we have to draw a diagram like this first, isn't it? In one of the diagram, the weight of the body in air is taken. Yes, and its weight should be one W1. Weight should be taken W1 and empty beaker W3. And in second figure, you can make second figure in which the body is immersed and new weight is W2 and combined weight here is W4. And showing all this diagrammatically, you have to write something. Okay, let's take this diagram to one of the side. Now, what is shown in the diagram? We have to write that. As shown in the diagram, a body is weight in air, its weight in air is W1, and then in water, weight in water is W2. Weight of the empty beaker is W3, and beaker with displaced water W4 is also taken. We have to say this, which is shown in the diagram. And then we can say here, upthrust is equal to W1 minus W2, but weight of displaced water equal to W4 minus W3, and experimentally W1 minus W2 and W4 minus W3 are found to be equal. It means weight of displaced liquid is found to be equal to the upthrust. Thus, Archimedes' principle is experimentally verified, which states that upthrust is equal to the weight of displaced liquid. This way, we can verify Archimedes' principle by writing, isn't it? The animated picture can be understood clearly, but while writing, we have to say this way. Okay, after this, I want to derive this Archimedes' principle. I mean to say, upthrust is equal to weight of displaced liquid. This is the heart of the Archimedes' principle. It can be proved mathematically also by derivation. Now, I want to do by derivation also. Look at this. Let's say we have a container, or we can say vessel, a vessel, and this is the surface of water in the vessel, and a body is immersed in it. Let's say this is a body immersed into it, and depth of the liquid up to the upper surface of the body is, let's say, S1, and depth of the liquid up to the lower surface of the body is, let's say, S2, and we know that pressure is acting through all the sides, but the pressure and force acting from all other sides cancel each other, but the pressure acting on this surface is less than pressure acting on this surface. Pressure acting on this surface and this surface are equal, and force acting on these two surfaces are also equal. That's why they cancel each other. In the same way, the force and pressure acting from front side and back side is also equal, and they cancel each other, but the pressure from acting from the bottom of the object is greater than pressure acting from the upper part of the body, because pressure of liquid depends upon depth of the liquid. The lower side, this side, is at greater depth, but this side is at less depth. That's why pressure at this place is greater than this place. So, pressure equal to force by area, even after being equal area at this side and this side, their area is equal. Even after being equal area, why pressure is more at this lower surface? Why pressure is more? Certainly, force acting from the lower surface should be more than the force acting from the upper surface. If force acting from the upper surface is taken as F1 and force acting from the lower surface is if taken as F2, then the resultant force applied by this liquid on this body will be F2 minus F1, and this is the upthrust. This is upthrust. Now I am going to use this equation also here. Okay, I want to mention one equation, P equal to HdG. You are taught this in class 8. Pressure of liquid depends upon depth of the liquid, density of the liquid, and acceleration due to gravity. These three factors affects the pressure of liquid. You are taught this, and we use this for the calculation of pressure in lower classes. Now, I want to compare this with this. for this upper surface, instead of P, we have P1. If it is so, then height of the liquid is S1 and density of the liquid is same D and G also same for a place. P1 equal to S1 dG. But we can write P1 as F1 by A. Why? Because force acting on this surface is F1 pressure equal to force by area, and force acting on this surface is F1 and area of this surface and this surface both are equal. That's why instead of writing A1 and A2 I am writing just A. F1 by A equal to S1 dG, and if it is so, then F1 is equal to S1 dGA. Okay, this is the force which acts from this surface. Similarly, F2 is equal to S2 dGA. It's very simple to understand. Like this, F2 is equal to S2 dGA, and we have already concluded that we know that upthrust in this case is equal to F2 minus F1 in all the cases. Why for this case only? Upthrust on this body is the difference of force acting from lower surface and upper surface. That's why F2 minus F1, I can put the value of F2 and F1 here. F2 is S2 dGA and F1 is S1 dGA, and this is equal to, if dGA is taken as common, then we will have S2 minus S1. This is upthrust. Now S2 minus S1 is the height of this body, isn't it? S2 minus S1 is the S. That's why I can write here as this is dGAS, and all of we know that area into height is volume. That's why I can write this as dGV. This is one of the important equation which is used to solve the numerical problem related to the pressure and related to the upthrust. Upthrust can be calculated if density of liquid is known and volume of the liquid displaced is known. With the help of density and volume and using G, we can calculate upthrust. Okay, now we know that density equal to mass by volume. We know this. Yes, that's why in place of density I can write mass by volume, and G, V remains same, V cancel. Therefore lastly what we get, U equal to mg. What is m? Mass of displaced liquid. What is G? Acceleration due to gravity. And if mass of displaced liquid is m, G is acceleration due to gravity, then certainly weight of displaced liquid is equal to upthrust. Therefore upthrust is equal to what? mg means weight of displaced liquid, weight of displaced liquid. Thus it is proved. What is proved? Archimedes principle is proved. Archimedes principle says that upthrust is equal to weight of displaced liquid. By the derivation we proved upthrust is equal to weight of displaced liquid. The previous one was experimental verification of Archimedes principle. It was what? Proof of Archimedes principle by derivation. Okay, now after this I want to talk about the use of Archimedes principle. Why we are talking a lot about Archimedes principle? Because it is used in different sector and very important use. Now let's have the use of Archimedes principle. Archimedes principle is used to build what? Hydrometer. To build hydrometer. I want to show one hydrometer to you. This is hydrometer. Hydrometer is a device which is used to measure density of the liquid. Yes, this is one of the example of hydrometer. It consists of two parts. One is narrow tube which is long, and the narrow tube is connected to a wide cylinder and at the bottom of the cylinder it is filled with lead salt or mercury salt to make it heavy. It is made heavy at the bottom because when it is placed in liquid, then it should remain vertical in the liquid, and when it remains vertical in the liquid, then certain value of density coincide with the level of liquid, and this is direct measurement of the density of that liquid. This way we use this hydrometer to measure density of the liquid. Now I am going to use this. Actually this is the alcoholometer, which is designed to measure the purity of alcohol. But somewhere maybe lactometer, hydrometer maybe, lactometer also. Lactometer is used to measure the purity of milk. Only the number, I mean to say the value of density on the stem is different. Otherwise, principally lactometer, alcoholometer is hydrometer. Now I'm going to use this to show you how it measures density of liquid. Once, let's say this is water, I am going to immerse this in water. This is alcoholometer, that's why there is no alcohol at all in this water, so it will show 0. Look at this. I want to turn it towards you. It will move a little, but when it comes to rest, then you can see the percentage of alcohol is 0, isn't it? Now if the same is taken in spirit, spirit is 100% alcohol if there is no any impurity. Now it will sink in spirit. Look at this. 100% alcohol is shown here. Now the level of liquid which coincide with certain value of density taken in the stem, that gives direct measurement of the density of that liquid. This way hydrometer is used to measure the density of the liquid. It will keep on moving a little and lastly it comes to rest, then we can see the value. I told you about hydrometer. Now Archimedes' principle is utilized in making hydrometer. Now next, what is the use of Archimedes' principle? To move submarine into the sea. How? I want to show with some animated picture. This is submarine. Submarine moves inside the water in the sea, and this is the level of water shown here. At this time, a part of the submarine is outside the water, a part is inside the water. And these are the water tanks, which are also called blast tank. And if this water tank is filled with water, it becomes heavier than the previous. Now the upthrust cannot support this submarine to make it float. It goes down because weight is more, because this blast tank is filled with water. Now if it has to move downward, then certainly the front side of the blast tank will be filled with water, then the front side tilt down, and using the motor and engine it can be driven to the downward direction. But if it has to come up, then rear part of this submarine should be filled with water like this. Now the front side tilt towards the upward direction, and using the engine the submarine moves upward. This way it works, but throughout its working, going down or coming up, Archimedes' principle is utilized, which says that upthrust is equal to weight of displaced liquid. Okay, let's have another point also. Archimedes' principle is used to fly hot air balloon. Look at this balloon. Very nicely, this balloon is flying very nicely, isn't it? And in its flight, actually Archimedes' principle is being used. How? Look at this is the basket of, this basket is shown in this picture very nicely. In this basket there are certain people and they are using fire to make the air warm. This balloon is filled with air and this air is being heated. And when air is heated, then what happens? The hot air plus the weight of the balloon, weight of hot air plus the weight of the balloon, combined weight is the weight of this balloon as a whole. And upthrust will be equal to weight of displaced air. Since air is hot, so it displaces more weight of air and upthrust will be more if air is heated. And upthrust is more, that's why it goes up. But when the same air cools down, then combined weight of the air and with balloon will be less than the upthrust and it comes down. This way, according to the requirement, when we heat the air contained in this balloon, then it moves up, and when the same air cools down, it moves down. Archimedes' principle is working at this time. Okay, now next, there is another point to move the ship into water from land. If we have to move a ship into water, first it is made on the land and later it will move it to water. This way we'll move it to water. But at the beginning it takes a little time to make it straight. It is made in such a way that when it emerges a little, it will be able to displace the liquid equal to its own weight, and then only it can float. This way Archimedes' principle is applied when the ship is moved into the sea. Okay, after all this, what I told you, what is Archimedes' principle and experimental verification of Archimedes' principle and use of Archimedes' principle, and I told you about the derivation also by which we can prove Archimedes' principle. Now let's have a question. Whether the subject matter is understood or not clearly, I want to verify with the help of this question. Answer the following questions with the help of the given diagram. Here we have diagram. Question is coming. First question is, what will be the weight of the body in air? This is the weight of the body in water or liquid is given here. Whatever it is, maybe liquid or water. But what is its weight in air? Weight in air is equal to weight in liquid plus weight of displaced liquid, upthrust. We know about this, that's why we can say that weight of this body is 12 Newton in air. Now next, how much upthrust is exerted by the liquid on that object? What is the value of upthrust? According to Archimedes' principle, upthrust is equal to weight of displaced liquid. Here weight of displaced liquid we have, it is 2 Newton, that's why upthrust must be 2 Newton. We can answer this way. Now next, calculate the mass of the body. Now we have to calculate mass of the body. If we are going to calculate mass of the body, then first we must have weight of the body in air. Weight of the body in air is previously decided that it is 12 Newton. That's why I want to calculate this. Weight of the body in air is equal to what? Weight of the body in air is 12 Newton, previously decided. And we have to calculate its mass. We have W equal to mg and weight is given 12 Newton, and mass we are going to calculate, value of g we are using 9.8 meter per second square, or 12 Newton, if 9.8 is taken to left hand side, 9.8 meter per second square equal to m. Now elaborated form of Newton is kg meter per second square, that's why I can write kg meter per second square here, and meter per second square cancel. Therefore m is equal to 12 divided by 9.8. I am using calculator. If we divide 12 by 9.8. Now the result is 1.2244. 1.2244, 1.2244 means we are taking just 2 digits after the decimal point. That's why I am going to ignore these digits, and 1.22 is the final result and its unit is kilogram. That's why mass of this body is 1.22 kilogram. Now let's go to another question. In which law the experiment is based? Law is told, but we know that it is based on Archimedes principle. That's why we can say that it is based on Archimedes principle. State the law in which experiment is based. We have to write the Archimedes principle. According to Archimedes principle, when a body is partially or completely immersed in a liquid, it experiences an upthrust equal to weight of displaced liquid. We have to write this. Okay. Now I think I made you very clear about the Archimedes principle. Now I want to stop this class. In next class we will meet with some another matter. Now I want to stop. Thank you.